All right, on to more word problems using SOHCAHTOA. We did the previous one, we did the angle of elevation and depression. Now we're going to do what's called bearing angles. Okay, you can see what I have here outlined in the red. You can take this down. Here's the big difference. Now when we are given an angle measure for a bearing angle, it's the angle between the path of direction that you're going, whether you're going northwest or northeast or southwest. It's between where the flight that you're going and the vertical line. Okay, so now it's the vertical line, not the horizontal line. Now, it doesn't mean that the vertical line is going to be in the right triangle. It might actually be on the outside of the triangle. Or we're going to see some examples like that in class. On this, we're going to keep it real basic. Number one is actually, you can see it's angle of elevation and depression, but I don't know what snuck its way on here. We'll do that one in class. On this video, we're going to do 2 and 3. All right, so let's take a look at number 2. And you'll see with this, just like angle of elevation and depression, the hardest thing is just interpreting the word problem and drawing the right triangle. Once you have that, it's real easy. Just use SOHCAHTOA. All right, here we go. So we have a ship leaves port at noon and has a bearing of 27 degrees southwest. All right, so let's get our directions right here. Okay, southwest. Now, what I always like to do on these bearing angle problems, I'll always draw a vertical line. I'll make it dotted. And if it's southwest, from here, this is southwest, right? This is the direction it's going. So I'll put arrows. That's southwest right there. Don't understand that? I guess look up a compass. I don't know. So this is 27 degrees. So I'm going to put 27 degrees right there. Okay, then we have it's traveling at 20 miles per hour. How many miles south and how many miles west is the ship from its departure point at 6 p.m.? So right up here, it left at noon. And when it got exactly south and west of this point, it's 6 p.m. Now this 20 miles per hour, this is real important. We cannot use miles per hour as a distance. Right? That's a rate. It's not a distance. So to figure this distance of which it traveled from noon to 6 p.m., you got to use our good old distance equals rate times time formula. So I have distance. Now saying the rate is 20 miles per hour. The time, if it went from noon and then it wants to see how far it traveled to 6 p.m., that's 6 hours. So a little easy computation there, 20 times 6. That distance that it traveled in those 6 hours is 120 miles. So this, I'm going to get rid of this question mark. I can replace it with 120 miles. And then I'll just finish the right triangle. Here's the right angle. All right, and it says how many miles south and how many miles west is the ship from its departure point? So we want to find when it's here, how many miles south? Well, we'll say this is, I'm going to say this is Y. And how many miles west is the ship? So obviously where we end, we're west of where we started. So we'll say this is X. So I want to solve for X and I want to solve for Y. Okay, I want to get rid of the distance equals rate times time formula. Now we're going right to SOHCAHTOA. So if I use the 27 degrees, the opposite side right here, I'll just put O, or I'll put opposite side for X. The adjacent side for 27 degrees is the Y. And 120 miles, this is the hypotenuse. Let's say we want to find X. So if I want to find X, I have the opposite and I have the hypotenuse. I'm going to use sine. So sine of 27 degrees equals opposite over hypotenuse. It's X over 120. And remember, it's like taking this and putting it over 1. If you cross multiply, you get 120 times the sine of 27 degrees equals, well here, X times 1 is just X. And then just put that in, 120 times the sine of 27 degrees gives us 54.5. Okay, and this is miles. So I'll put miles. Now, this is what we got right here. This is miles west. Okay, so we solved for that part. So I'll even cross that. We solved for west. Now I have to solve out how many miles south did it go. Okay, so I'm just going to basically erase everything that I did, use another trig function, because now this is what I want to solve for. I want to solve for y. All right. Okay, so if I solve for y, I'm still going to use the same thing with the opposite side, the adjacent side. Now I want to find the adjacent side, and I'm going to use the 120. I know you could use the 54.5, but let's make it as accurate as possible. So they gave us 120. Let's use that. So now if I have adjacent and I have hypotenuse, that's a and h, that's the cosine. So I'm doing cosine of 27 degrees equals adjacent over hypotenuse, so it's y over 120. Yeah, it's like taking this cosine 27, putting it over 1. So when you cross multiply, it's 120 times the cosine of 27 is going to equal 1 times x, which is x. So if you make sure you're in degree mode, you put that in, and you should get your x value to be, excuse me, this is your y value. Let's erase that. Okay, so you should get your y value to be about 106.9 miles south. Let's put miles south. All right. So there it is. Here's the big thing, the bearing angle. It's between the flight that you're taking, right, the path that you're taking, and the vertical side. All right. Let's do one more. Let's do number 3. So I'm just going to erase some of this stuff here so it doesn't get in the way for number 3. Okay, let's move this up. All right. Now number 3 is a little bit different. We're given distances. What we want to find is we want to find what bearing it should be taken. Now, there's 2 things you have to find for bearing. Number 1 is the direction. Are you going northeast, northwest, southeast, or southwest? And then the other thing is the number. Like, what is the angle number that you're going? So let's draw this right here. It says a plane is 120 miles north. I'm going to say this is the plane right here. Okay, unlike the PowerPoint, I can't draw pictures right here, so I'm just going to put dots. This is the plane. Now, it's saying it's north and it's east. So if it's north, I'm just going to draw this line down here. And it's east of an airport. So if it's east of it, here's where the airport would be. So I'll put airport. Okay, and this is my right triangle. Okay, and it's saying a plane is 120 miles north, so that's the vertical part. And it's 85 miles east of an airport. This is the horizontal part. Okay, and I'm saying if the pilot wants to fly directly to the airport, what bearing should be taken? Now, this is the plane. This is the direction it's going right here. So remember I said first, let's find the direction. Now, if this is the direction, then you can easily tell we're going southwest. It's got to be the opposite of where the plane is located from the airport. So if it's north and east of the airport, well, you got to go the opposite, southwest. So I'm going to put southwest here. And the bearing, remember, it's between, this is the flight it's going with the arrows, and the vertical part. So this is what we want to find. So now when I use this, if I use theta, 85, this is the opposite side. 120 is the adjacent side. So I have those two, opposite and adjacent, that's the TOA, so we're going to use tangent. So I have tangent of the bearing angle, which is just theta, equals opposite over adjacent, which is 85 over 120. Now remember, when you have to solve for the angle, this is where you have to hit inverse tangent. So on your calculator, this is where you're going to put in second tangent or inverse tangent of 85 over 120. When you put this in, it should give you your answer. And your answer should be about 35.3 degrees. And don't forget to put the direction southwest. All right, so bearing angles, remember, main difference is it's between the path that you're going and the vertical part of the triangle. We'll do more of these tomorrow. And look at more difficult ones on the back of this worksheet tomorrow.